Hi, welcome to section 2A, not 2 point anything, sorry. Section 2A we are going to be working on. It's the start of unit analysis, and units are done a different way from what you're going to want to do them. Everybody wants to do them the way that's kind of intuitive for them. And a lot of people want to try to do them in their head, and the more you try to do it in your head, the more likely you are to get it wrong. You're going to want to do it in your head, and you're going to want to kind of, because it's going to make sense for you to do it in your head. You're going to think, oh, I can just do this in my head. And if you actually take the time to do it on paper, then you're going to get it right more often. A lot of people who do them in their head get it right every once in a while, but if you do it on paper, you'll get it right all the time. So it's better to try to do it on paper all the time as opposed to doing it in your head and getting it right every once in a while. That's where everybody tends to make their mistakes. So try to stick with the paper version of things, and I'm going to show you how to do the paper version of things, and everything's going to just flow and it'll all be okay. If you don't do the unit analysis, and if things don't work out the way that I show you, then you tried to do it in your head and follow your gut, and it doesn't quite flow the right way. Gets kind of sad in the end. So we're going to stick with what we know works. So units are words that describe what is being measured or counted. This is not blue. I want it to be blue. Blue. It says it's dark blue. It doesn't look blue at all. Does it look blue to you? It doesn't look blue to me at all. Blue. I want blue. 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 I want blue. Blue. Try again. Unit analysis is the process of working. There we go. Working with units. It's still kind of too dark of a blue, but I think you'll be all right. I wonder if it'll let me lighten it up some. I can do more colors. So I can lighten it up just a little bit. Let's do that one. Okay. So there's some key words you're going to want to look out for. Our class is specifically dealing with word problems. I mean word problems all the time. All the time. All the time. So we've got to learn to deal with the word problems, and word problems aren't really hard if you know the code. So if you can match words with symbols, a lot of times it makes your life simpler. So the word per will always go with the operation of division. For example, you'll have miles per hour. Whoa, stop jumping. Why are you jumping? I don't like it. I know what that is. Hold on just 1 second. Let me see if I can move this out of the way. You can see it written as a fraction, which is the same thing as saying miles divided by hours, or you could actually say miles per hour, which is how we term it, miles per hour. Of, or a hyphen, means to multiply. I know what it is. It's a shortcut for this pen. It's the shortcut for this pen. That's what it is. So when they say, kilowatt hours, that's the same thing as saying kilowatt times hours. Square is raising to a second power. For example, feet times feet is feet squared. You can say square feet. Well, square feet. Or you can say feet squared. Either way is fine. And this is raising to a third power. Feet times feet times feet, which would be feet cubed. So you can say cubic feet or feet cubed. Either way is fine. A unit conversion has a conversion factor. The conversion factor can be written in two different ways. It's a ratio or a fraction that can be represented two different ways. You always need to start with the question first. And we'll show you some examples where that's very, very important. I think there's only one example in here where it's not quite so important to start with the question first. You can start with the conversion factor first to make it make more sense for you. But for the most part, always start with the question first. You need to find the conversion factor or the unit relationship that includes that unit. Put the relationship into a fraction with the common unit on the bottom. That's the important part. As the original one was on top, making sure you put the two numbers with the correct units. If there are units in your table that you do not want in your final answer, cancel them out by putting that unit in the opposite side of the fraction. When you have no more units to cancel, you end up with the top in the desired unit you want the answer to be in. Remember, the units on top will cancel out with the units on the bottom. That's the point. Multiply the numbers straight across the top and divide by every number on the bottom to get your answer. That's what they try to get you to do. Oh, look, it pointed in the wrong direction. I don't know if I can get that to go away now. Look at that. Editing tips. Well, that's not helpful. Nope, unhelpful. Okay. It won't erase my little mark. Good to know. Did I mention this is a curve for me to learn to? Alright. They want me to convert 16 feet to yards. This is when you have to start learning. This part I know. Okay. We start with what we know, 16 feet. So I'm going to put my 16 feet. Technically, it's on top of the fraction because it's what we know. Technically, if you want to say there's something on the bottom of the 16 feet, it would be the 1 that's on the bottom of that fraction. But generally speaking, we don't write the 1. I want to multiply this by something to make that feet go away. What do we know about feet and yards? So now is when you're going to have to search your mind and think, what do I know about feet and yards? This is something that you have to consider because you're expected to actually know this information. Like, this is something that you're going to have to know. This is not something that we're going to tell you. This is not something that you're going to be able to look up. This is something you're going to have to know. So if you come across something in here that you don't know, that we don't tell you in the problem, then that means that you're going to have it memorized. That's right. So as we go through these problems and these examples, if there's something that you don't know, then you need to make a mark by it or highlight it or something so that you can make a list of those things and make sure you memorize them before we get to the midterm, because you're not going to have that information given to you on the midterm. So, what do we know about feet and yards? Well, if I go back in my memory, I happen to know that there are 3 feet in every 1 yard. That's something I know about feet and yards. So, since there are 3 feet in every 1 yard, I have to make a fraction out of this. I can make 2 different fractions. I could say that the 3 feet goes on top and the 1 yard goes on bottom. That's a true fraction. It's equal on top and on bottom. That's all we've got to have. Or I could say the 1 yard goes on top and the 3 feet go on bottom. Either one of those would work. I could use either one of them. I have to know which one we need. Well, the problem is I need to be able to cancel out the feet because we don't want our answer in feet. We want our answer to be in yards. Which means I'm going to need the yards to be on top, not the feet to be on top. Right now we have the feet on top. I don't want the feet on top. I want the yards on top. So if I want the yards on top, I'm going to want the fraction over here out of my 2 fractions that has the yards on top. Well, the one of these that has the yards on top is this one. So that's the one I'm going to choose. Incidentally, it's also, don't shade it. Can I get it to undo? Undo. Oh. Maybe. Undo. There we go. Okay. So I don't want the feet on top because I need the feet on the bottom. When I have 1 yard on top and 3 feet on bottom, something magnificent happens. Magnificent happens. What happens is when you have the same unit on top that you have on the bottom, that allows your units to cancel out. If you have the same thing on top that you have on the bottom, they can cancel out. This only works when you're multiplying. If there was some other operation there, if there was division there or addition or subtraction, it wouldn't work. You have to be multiplying. But because we're multiplying, this works. So that's why you always want to make sure you're multiplying in this. So because we're multiplying, because I have my feet on top and my feet on bottom, that means my feet can cancel out. That means the only unit I'm left with is yards, which is really good because that's what we wanted. We wanted our yards to be on top. So now I can multiply across the top and divide by the bottom. When I multiply across the top, I get 16 times 1, that's 16 yards on top. And on bottom, I'm left with 1 times 3, which is just 3. That's cool. So I get 16 over 3 yards. You can leave your answer as 16 over 3 yards because it doesn't reduce. So you could say 16 over 3 yards. That might not be a choice if it's multiple choice. They might want you to say 5 1/3 yards. Either one of those I would take as correct. One of them is improper, one of them is a mixed number. Either one to me is correct, so I'm good with either one. They didn't say which one they wanted. I'm cool with either. In the next one, they want you to change 17 years to days, neglecting leap years. Okay, so we start with the information they gave us. That was 17 years. We have to multiply it by something. What do we know about years and days? Well, the information I know is that 1 year equals 365 days. Okay. I can make two fractions out of this. I could put the 365 days on top or the 365 days on the bottom. Where do you think I want to put the days? I want to put it on top because we're looking for days. So I want to put my 365 days on top. Put my 1 year on the bottom. So my years get to cancel out. That's good. That's what we wanted because one's on top, one's on bottom. They get to cancel out. Which means we're left with days. Multiply across the top and divide by the bottom. 17 times 365 is 6,205 days over 1, which is just 6,205 days. That's not bad. See? Rolling right on along. Then they want us to convert 45,789 inches to miles. Okay. Start with what I know. 45,789 inches. Gonna have to multiply this by something. It's supposed to end up with miles. What do we know about inches and miles? Do you know how many inches are in a mile? No, I don't either. Don't go to Google. We're supposed to be able to do this without that, remember? We might have a problem. What do you know about inches? Well, do you know how many inches are in a foot? Let's start there. I know that there are 12 inches in 1 foot. Then I happen to know, you may not, but I happen to know that there are 5,280 feet in 1 mile. So I can get to miles just off the information I know. So when I'm doing this, do I need the inches on bottom or on top? I'm going to have my inches on bottom so they'll cancel out. So I'm going to have to put the 12 inches on the bottom and the 1 foot on top. Well, that's okay, because we want our inches to be able to cancel out. But that doesn't leave me with miles, so I'm going to have to multiply again. So we're going to have more than one fraction. That's okay. For my next fraction, I need to have feet on the bottom, so it'll cancel out. So my 5,280 feet, that's going to have to go on the bottom. And my 1 mile is going to have to go on the top. So my feet can cancel out. Multiply across the top. 45,789. That's miles. Multiply across the bottom. I didn't write down what that was. Hold on. Grab my handy dandy calculator. That's 63360. Now I can do my division and get 0.7226799 ... Keeps on going for a ways. That's okay. We're going to go ahead and round it off to about 2 decimal places. So that's 0.72 miles. They didn't say where to round it, and if they don't tell you where to round it, technically you get to choose where to round it. That's your prerogative. I like to pick a small number so that it's an easy round, but that's just where to round. When you're doing conversions, you want to deal with your yards squared and your feet squared very carefully. So there's a picture here where you have 1 yard by 1 yard, and you can see that it's different from 1 foot by 1 foot. So 1 yard might be 3 foot, but you can't say that it's 3 times 1. So you have to be very careful about how you do feet squared and yards squared. So they suggest that you raise each of them individually first before you start doing the multiplication, but you don't necessarily have to do that. You just have to be careful about your stuff. So I'm not going to show you all the intricacies. I'm going to show you a shortcut that will always work as long as you're careful. They want to know what the area in square feet of a 100 yard by 60 yard football field is. Area is length times width, right? So all I need to do is multiply these. So that means my area is going to be 6,000 yards squared. But they asked for it in square feet, not in square yards. So we're going to have to switch it to feet squared. In order to do that, I'm going to take my 6,000 yards squared change it to feet squared. All I need to do is change my units. That's all. What do we know about yards, feet? We said earlier that there were 3 feet in 1 yard, right? So 3 feet in 1 yard. I know my yard has to go on the bottom. But I don't have just 1 yard up here. I have 2 yards up here. I know I have 2 yards up here because there are little 2 up there. There's a 2 right there. There's 2 right there. So I have to have 2 of them. I only have 1 of them down here. I'm going to have 2 of them down here to cancel out that. So I'm going to have to do another 1 yard down here, which means I got to have another 3 feet up here. So in order to get rid of that yard squared, I've got to have 2 yards down here. Which gives me 2 feet up there. It's okay. That way it'll be in square feet. That's what we wanted. Okay. So now I can do my multiplication across the top. 6,000 times 3 is 18,000. Times 3 more is 54,000. Feet squared over 1 times 1, which is 1. That leaves me with 54,000 feet squared. A hot tub pumps. The hot tub pump circulates 3.5 cubic feet of water per minute. 3.5 cubic feet, that's feet cubed, water per minute. Per minute, it means it's going to equal 1 minute. Per means the 1 minute has to go on the bottom. We talked about that, right? So it's 3.5 feet cubed per minute. How many cubic inches of water does it circulate each minute? They want it in cubic inches. So I got to change it from cubic feet to cubic inches. What do we know about feet and inches? We said that 1 foot is 12 inches. But I can't do it just 1 time. I got to do it 3 times. So my 3 feet down there will cancel out with my 3 feet up there. That leaves me with cubic inches up top. 3.5 times 12 times 12 times 12 is 6,048 inches cubed per 1 minute. I'm going to skip example 6 and example 7. I'll tell you why in a second. And I'm going to go to currency conversions and talk about exchange rates. When you're dealing with exchange rates, you're going to see charts like this a lot. And you need to understand that whenever you're dealing with a chart like this, or whenever you're dealing with anything, you're going to want to try to keep the 1 on the bottom. If you can keep the 1 on the bottom of your fraction, that'll make your numbers more accurate. They'll be close, but they'll be more accurate. If you use the other number, it'll be a close proximity, but it will not be quite as accurate. Whenever you're in My Math Lab, you're going to want the most accurate number possible. So please try to keep the 1s on the bottom, if at all possible. So, in order to do that, you're going to want to make sure you pick the right fraction all the time. We talked about how to pick the right fraction before. I want to make sure you always pick the right fraction. So here they talk about dollars per foreign. That's American dollars per foreign. Over here, they're putting the foreign currency on top of the dollar. But they're giving you decimal points. So they're assuming that whatever's on the bottom is always going to be a 1. So it's 1 foreign, whatever it is, or $1, whatever it is. They're always going to have a 1 underneath. And these numbers are the numbers that go on top. These are always your top numbers on both sides. These are always the top numbers. It's the number, it's a 1 always on the bottom. So that you understand. That's how you know. So if you want to have the yen have a 1 on the bottom, if you want the yen to be on the bottom, then you want to make sure you pick it so that you have 1 yen on the bottom. You don't want to use the Japanese yen over here where you're going to end up with a $1 on the bottom. That's not going to be helpful. So you want to make sure you end up in the right spot. So when we're doing example number 8, the hotel rate in Tokyo is 45,000 yen per night. What is the nightly rate in US dollars? I need to multiply this by something so that we end up with dollars on top, because that's what we want our answers to be, US dollars. If that's the case, we want our dollars to be on top. That's this column. So we want our yen to be on the bottom. So I go where Japanese yen is. This puts the dollars on top. So this is my dollars number on top, but my Japanese yen is the foreign that goes on the bottom. So this is over 1 yen for this dollar amount on top. So that's 0.009694. And these numbers change all the time. So your book will always tell you the number they want you to use, or My Math Lab will tell you what number they want you to use. The exam will tell you what number they want you to use. But they're going to be different all the time, so make sure you pay attention to them. Multiply across, divide by the bottom, make sure you cancel out your units. We still have dollars on top, so the dollars get to stay. When I multiply across and divide by the bottom, I get $436.23. Whenever we're dealing with money, you always want to round to the nearest cent. Now, we have gone through and we ended up skipping example 6, and we skipped example 7, and we're skipping example 9. Let me explain why. I took time out and did not do example 6, example 7, and example 9. Here's what's going to happen. You need to have a little bit of time to practice. So there will be a space inside of Blackboard where I put the answers to example 6, example 7, and example 9, so that you can find the answers to example 6, example 7, and example 9. But I want you to have a chance to go through and work on them first before you ever try to get an answer to them, before you ever get to hear an answer to them. So please make sure you go through. If you would like to see me work out example 6, example 7, and example 9, that's not a problem. All you have to do is email me and ask me. I'll be happy to make a video of it and have it sent to you or post it. That's not an issue at all. But do try them. The answers to them will be posted somewhere in Blackboard. I haven't figured out yet where that's going to happen, but it'll be posted somewhere in Blackboard. It'll be easy to find. But example 6, example 7, and example 9 will be posted elsewhere. I want to make sure you get a chance to try them. Okay? Please, 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 please try them on your own. Make sure you understand them. Then you can go work on your homework for section 2A. Have a lovely day.